So on your desk, you have a paper that's entitled like task 1. Turn over. There's task 2, 3, and 4 on the back side. Due to my absence today, we're only going to look at task 1, and then we will discuss task 2 and 3 when we meet next. Make sure on Monday when we meet next that you bring your computer, because task 2 and task 3 are actually we're looking for the formula. We have to find the approximate value for R, and we're going to be using decimals as a way of helping us establish that estimate. So today we're only going to be looking at task 1. So for the equations that are presented to you, the recursive formulas, the recursive formulas that are presented to you on the front page at the bottom, what I'd like you to do is to go through the problems, and I'd like you to establish, based on the problems, is the problem, 3 categories here. So I'd like you to identify, is each problem, first of all, arithmetic, geometric, or shifted? Is the problem going to have an increase? So is it a growth, or is it a decay? Is it based on the last video, I talked about the fact that sometimes, especially with shifted, you may have to go through a series of steps by actually putting in a number and checking to see if the sequence goes up or down. And then is it linear, or scrapping it, or would it be non-linear? So I'm going to put some letters here. So I'm going to use A, G, and SG for my approximation for arithmetic, geometric, shifted. I'm going to use I and D for increase, decrease. This is basically growth, for example. And this is a decrease, we like to call decay. And then use the letter L and N for linear and non-linear. So you go ahead and look at each of the problems and decide from each category which letters to give each recursive formula. So you're going to do an AG, SG, and plus a ID and also an LN. So every sequence will have 3 letters, 1 from each category. Turn the video back on when you're ready to check answers, or if you're just ready to get more information for the first problem, and then try the next problem on your own, that's fine as well. All right, so problem A, it is a subtraction problem only. So if you have it adding a positive or adding a negative, that's an arithmetic sequence. In terms of if it's going up or going down, if I take 8, subtract 2, I get 6, subtract 2, I get 4. If I keep subtracting 2, it means it's going down, so this will be a decrease. And because every time I go to the next answer, I'm decreasing by 2, that is a constant decrease, and that's going to make a linear graph, or a set of points that have the shape of a line. To this point again, turn the video on if you used letter A just kind of to get some more information. Try to work on your own, and then turn the video back over here and continue. So problem B, we're looking at geometric, it's multiplication. It is a decrease in answers, because 8 times a half is 4, times a half is 2, and so on. And all geometrics are nonlinear. So the distance between the points is not the same answer. So I go from 8 to 4, which is the difference of 4, to 4 to 2, which is the next answer. It's the difference of 2. So since the difference between the points is over from one answer, so that's not the same answer, or the same distance, that makes the graph curve nonlinear. Problem C, it is another geometric with multiplying. And I'm taking a half times 2, which is 1, and then I'm going to double 1, which is 2, I double 2, get 4, so it's an increase. And again, it's a geometric, so it's nonlinear. All geometrics are nonlinear, arithmetics are always linear. Problem D, it's an addition problem, so it's arithmetic. I am adding 2 each time, so I'm going to look at -2 plus 2 is 0, plus 2 is 2, plus 2 is 4, so on. That's the increase. And it's, again, arithmetic, so it's linear. Problem E, you'll notice that there is, there's no number, which means that's a 1. And there's no number at the end, which means that that D value, that difference, would be 0. So this one here, the answer actually is going to be -4, -4, -4, -4, and so on. So in terms of a graph, it's definitely going to be linear. And in terms of the sequence itself, you could probably make the argument that it's arithmetic because it is a linear. There is no increase, there is no decrease. The answers are always -4. So in terms of the shape of the graph, it's definitely linear. We're adding 0 every time. So that kind of makes it look like it's an arithmetic sequence. And there again, there's no increase or decrease. And the last one is shifted. So what I would do again is I would put in -2 to see what the answer is for U1. Find out is it going up or down. So half of -2 is -1, and I add 2 to that, I get the final answer of 1. So this is going to be a growth, so this is going to be an I, increase. We are doing a multiplication problem and an addition problem, so that makes it a shifted geometry. And again, all geometrics are nonlinear. So what I'd like you to do to finish up task 1 is just take a look at the problems A through F, and you're pairing A through F with tables and with the graphs to see which combinations go together. So go ahead, turn the video off, complete task 1 by comparing the graph, the equation, and the recursive formula and the table, and then turn the video back on when you are ready to check your final answers. All right, so for the table, problem A and B both start at 8, so that means that A is either number 1 or number 5, since they both start at 8. The nice thing with these tables is that we didn't go in order, so we're going to be missing the answer 2 here as well as here. So you got to kind of decide based on the problem. If I put in the missing answers, kind of build the table. Am I consistently doing a multiplication problem of have a half of B, or am I consistently reducing the answer by 2, which is A? So for example, here it's definitely a subtraction problem. And here, I am definitely, my choice is multiplying by half. Half of 8 is 4. So this is, number 1 is B, and number 5 is A, based on what we're doing in the sequence. Problem C is a half, and so we're looking for a half, the starting point, that is only one of those. Problem C is number 2. Problem 4, I'm starting at -2, and 5 also is problem F is also -2. For D, I'm looking at -2 and then adding 2. So if I'm looking at this one here, for example, if I add 2 and add 2 again, I would actually end up at +2. So I take -2 plus 2, my answer for 1 would be 0. If I add 2 to that, I would get that answer there. So this is problem D, which means that this here is problem F. And actually, I did this answer in the previous video segment, where I actually put in the -2 to show that the next answer would be 1. And then the last problem, from 6, that would be E, where I am basically, the next answer is going to always remain -4. It's not going to change. In terms of comparing up these graphs, I'm going to go ahead and start with this one here. That's problem E. That's where all the answers remain -4. This graph here and this graph here both begin at 8. That's A and B. A is the linear, because we're subtracting 2 each time, so this is A. And then B is geometric, so this is B. This graph starts at -2, as well as this graph starts at -2. So that would be F and D. D is linear, so this is D. And F is shifted geometric, so that's F. And then the last one here starts at a half, which is probably C. So in your your next homework assignment, which will be due next Wednesday, one of the things you're going to be asked to do on page 2 is be able to kind of connect the graphs with the recursive formula. And then on the last page of the homework assignment, what you're asked to do is given like a value in the recursive formula and ask if I put numbers in a certain range, like let's say between 0 and 1, what type of graphs should I expect to get, for example? Should I expect them to be geometric? Should I expect them to be arithmetic? Or shifted? Should I expect the graph to go up and down? Should I expect the graph to be linear or non-linear? This is it for task 1. If you have any questions on task 1, we can talk about that when we meet next. But make sure you bring the paper back so that we can complete task 2 and 3 on Monday. And again, make sure you have your computer because we're going to use some Desmos to help us complete those problems.